Picture a world so distant that sunlight, traveling at the fastest speed anything in this universe can travel, needs more than 4 hours just to cross the gap between it and us. A place where the wind doesn't just blow, it screams, moving faster than sound itself. A place where a single season stretches on longer than most humans will ever live. A place so brutally cold that if you stood there unprotected, the very air around you would freeze solid within moments. Now here's the part that really stops people in their tracks. For almost the entire span of human history, we had zero real knowledge of what this planet looked like up close. Not one clear photograph existed. All we had were faint smudges through telescope lenses and a mountain of educated guesses. Then, one day, a spacecraft that had been launched by humanity years earlier finally reached its destination, and everything we thought we understood about the far edge of our solar system got rewritten in an instant. If distant, mysterious worlds pull at your curiosity the way they pull at ours, go ahead and hit that subscribe button, because today we're diving deep into the story of Neptune, arguably the strangest, most violent, and most visually breathtaking planet in our cosmic neighborhood. Stick around until the end, because the final piece of this story is something that caught even veteran scientists completely off guard. Let's start with something so basic, it almost sounds boring until you actually sit with the number. Neptune orbits roughly 4.5 billion kilometers from Earth. Try to imagine driving there in an ordinary car at highway speed. No stops, no brakes, no sleep, nothing. That drive would take you more than 5,000 years to complete. Read that again, because it is not an exaggeration or a typo. 5,000 years behind the wheel. To put it in perspective, you would have needed to leave home before the pyramids of ancient Egypt were even built, and you still wouldn't have arrived. That is the kind of distance we're talking about. That is the world whose actual face humanity did not lay eyes on until the year 1989. Scientists classify Neptune as an ice giant, and that label tends to conjure the wrong mental image. Most people picture a frozen, silent snowball hanging in space, coated the way a forgotten bag in the back of your freezer gets coated in frost. The truth is far stranger. The term ice giant actually refers to the chemical composition hidden beneath Neptune's outer layers, not some icy crust on its surface. Neptune is built primarily from water, methane, and ammonia, but not in any form you'd recognize as ice, liquid, or gas in the traditional sense. These substances exist in what scientists describe as a supercritical state, a bizarre in-between condition where matter isn't quite liquid and isn't quite gas, but behaves like some blend of both simultaneously. Nothing like it occurs naturally anywhere on Earth, which makes Neptune one of the most alien environments found anywhere in our solar system. Only 2 planets earn the ice giant classification, Neptune and its neighbor, Uranus. Both are strange and fascinating, but as you're about to see, Neptune stands in a category all its own. The scale of this planet alone is enough to make anyone feel small. Neptune's diameter at the equator measures around 50,000 kilometers. Compare that to Earth, the planet that already feels massive to us, the planet you'd need over 24 hours just to fly across by jet, which measures only about 12,700 kilometers across. That makes Neptune roughly 4 times wider than our entire world. The mass difference is even more staggering. Neptune weighs in at approximately 17 times the mass of Earth. 17. If you somehow lined up 17 Earths on one side of a cosmic scale, they would just barely balance against a single Neptune sitting on the other side. Here's a twist that catches a lot of people off guard. Despite being so enormous and sitting so far from the Sun, Neptune actually spins faster than Earth does. A full rotation on its axis, what we'd call one day, takes Neptune only about 16 hours, compared to our 24. But flip over to the concept of a year, and the situation reverses completely. Because Neptune sits so far out, its orbital path around the Sun is enormous, and one full trip, what we'd call a Neptunian year, takes approximately 165 Earth years to complete. If a child were born on Neptune and wanted to celebrate their very first birthday using Neptune's own calendar, everyone back on Earth would need to wait until that child turned 165 years old by our clocks. Seasons follow the same absurd scale. Like Earth, Neptune tilts on its axis, which produces seasonal shifts. But while our seasons last a few months, a single Neptunian season lasts more than 40 Earth years. Try to imagine a winter that started before your parents were born and hasn't ended by the time you're well into middle age. That's simply how time moves on Neptune. Remarkably, scientists have now observed Neptune long enough to actually track these seasonal transitions through shifting cloud patterns and changes in atmospheric brightness, giving us a genuine window into how this world behaves across these impossibly slow cycles. The tale of how we even came to know Neptune existed is one of the great triumphs of human curiosity and careful math. Whispers of a hidden planet beyond Uranus go back further than most people realize. The Italian astronomer Galileo Galilei may have actually observed Neptune sometime between 1612 and 1613, recording it in his notes, but he logged it simply as a background star, never recognizing what he was truly looking at. More than 2 centuries passed before Neptune was formally confirmed. And what finally cracked the case wasn't a telescope spotting something new in the sky. It was mathematics. Astronomers tracking the orbit of Uranus noticed something wasn't adding up. The planet wasn't following the path it should have followed based on the gravitational pull of every known planet at the time. Something invisible was tugging at it. Multiple scientists, working separately, ran the numbers and arrived at the same conclusion. There had to be another planet out there, farther from the Sun, whose gravity was the missing piece of the puzzle. In 1846, Neptune was officially confirmed as a planet, its existence essentially proven through calculation before anyone even pointed a telescope at the correct patch of sky to look for it. That achievement still stands as one of the most remarkable feats of predictive science in human history. The name Neptune traces back to Roman mythology, honoring the god who ruled the seas and all the waters of the world. When early astronomers caught their first glimpse of the planet's deep blue-green hue through their telescopes, the comparison to the ocean felt obvious and immediate. It was one of those rare moments where a name simply fit on every level: the color, the mystery, the sense of vast, unknowable depth shared by both the planet and the sea. That striking blue color, the one that makes Neptune instantly recognizable, comes from methane sitting high in the planet's atmosphere. When sunlight reaches Neptune, methane molecules soak up the red wavelengths of that light, leaving mostly blue light to bounce back out toward our telescopes and cameras. The same chemical process happens on Uranus, too, since it also has methane in its atmosphere, yet Neptune consistently appears far more vivid and richly blue by comparison. Researchers suspect some other unidentified ingredient in Neptune's atmosphere is amplifying that blue tone, though exactly what that ingredient is remains an open question scientists are still chasing today. Now let's talk about the winds, because this is where Neptune truly earns its reputation as one of the most violent places in the entire solar system. Neptune holds the record for the fastest winds ever measured on any planet we know of, with gusts reaching up to 2,100 kilometers per hour. For comparison, the strongest hurricane winds ever recorded here on Earth topped out around 350 kilometers per hour. And those storms leveled towns and reshaped coastlines. Neptune's winds blow roughly 6 times stronger than that. They move faster than the speed of sound. These aren't gusts you could shelter from. They are walls of moving atmosphere at speeds that would be nearly impossible to survive. What makes this even stranger is that Neptune sits so far from the Sun that it receives almost no solar energy, roughly 900 times less sunlight per square meter than what reaches Earth. Normally, sunlight is the engine that powers a planet's weather. Neptune barely gets any, and yet it has the most ferocious winds of any planet we've found. Scientists believe the real answer lies deep within the planet itself. Neptune radiates significantly more heat outward into space than it ever absorbs from the Sun, which tells researchers it must have its own powerful internal heat source, likely a leftover remnant from the planet's violent formation billions of years ago. That internal furnace is thought to be the true driving force behind Neptune's record-shattering winds. One of the most iconic features ever captured on camera at Neptune is a colossal storm system photographed by Voyager 2 during its historic flyby. Scientists nicknamed it the Great Dark Spot, an obvious nod to Jupiter's famous Great Red Spot. This was an enormous, swirling storm roughly the size of Earth itself, churning through Neptune's southern hemisphere, with wind speeds along its edges among the fastest ever recorded on the planet. But when the Hubble Space Telescope later turned its lens toward Neptune in the mid-1990s, the Great Dark Spot was simply gone, dissolved back into the churning atmosphere as if it had never existed. Since then, other dark spots have appeared and vanished in different regions of the planet, suggesting these massive storms, despite their staggering size, are temporary visitors rather than permanent fixtures, unlike Jupiter's storm, which has persisted for centuries. The temperatures on Neptune deliver exactly what you'd expect from a world this far from the Sun, and then some. At the very top of the cloud layer, temperatures plunge to around negative 201 degrees Celsius, a level of cold that borders on incomprehensible. But travel deeper, down through Neptune's layers toward its core, and something shocking happens. The temperature climbs dramatically. Near the planet's center, scientists estimate temperatures could soar as high as 7,000 degrees Celsius, hotter than the surface of our own sun. That core is believed to be roughly Earth-sized, a dense sphere of rock, iron, and nickel buried beneath thousands of kilometers of superheated, crushed fluid. This staggering temperature swing, from unbearable cold at the cloud tops to sun-like heat at the core, is a major piece of the puzzle behind Neptune's internal heat engine, the same mechanism thought to be fueling those record-breaking winds we just talked about. It's a system with no real equivalent anywhere on Earth, and fully understanding it remains one of the great ongoing challenges in planetary science. Now, let's get to the turning point, the moment humanity finally saw Neptune's true face. Before 1989, everything we knew about this planet came either from mathematical predictions, distant telescope observations that reduced Neptune to little more than a faint, fuzzy disk or pure theory. No human being had ever seen this world in any real detail. That changed with the arrival of Voyager 2. Launched on August 20th, 1977, this spacecraft was designed by NASA to take advantage of a rare alignment of the outer planets, one that allowed a single probe to swing past several worlds in sequence, using each planet's gravity as a slingshot to build speed for the next leg of the journey. Voyager 2 visited Jupiter, then Saturn, then Uranus, before finally reaching Neptune's neighborhood in August of 1989, a full 12 years after leaving Earth. The images and data it beamed back during that flyby remain, to this day, the only close-up visit any human-made spacecraft has ever made to Neptune. The photographs were nothing short of stunning. People who had grown up knowing Neptune only as a faint blue point of light suddenly found themselves staring at a living world with genuine texture and detail. The deep electric blue coloring came through in vivid clarity. Bands of atmosphere revealed themselves, layers of clouds drifting at different speeds across the planet. The great dark spot appeared in full view, that massive storm ripping through the southern hemisphere. Smaller white clouds also showed up, and scientists nicknamed them scooters because of how quickly they zipped across the planet relative to the slower features beneath them. Researchers believe these bright streaks are clusters of methane ice crystals, forming high up in the coldest layers of the atmosphere. One of the most exciting discoveries to come out of that flyby was the confirmation of Neptune's ring system. Scientists had already suspected rings might exist based on inconsistent evidence gathered from Earth, but nothing definitive. Voyager 2 finally settled the question. Neptune does have rings, but calling them rings in the same breath as Saturn's rings almost feels misleading. Saturn's system is one of the most spectacular sights in the solar system, made of countless particles ranging from tiny grains of dust to chunks the size of houses. Neptune's rings, by contrast, are thin, faint, and dark, composed mostly of microscopic dust that is genuinely difficult to photograph even with strong equipment. What makes them especially puzzling is that the material isn't spread evenly. Certain sections, called ring arcs, are noticeably denser and more concentrated than the rest. These arcs are actually part of why earlier Earth-based observations were so inconsistent. Astronomers would sometimes detect something and sometimes detect nothing, depending entirely on which arc happened to be facing our direction at the time. Scientists suspect small nearby moons use their gravity to herd and confine this material, keeping the arcs from simply dispersing evenly around the planet, though the full explanation for how these arcs hold their shape is still being actively researched. Voyager 2 also completely transformed our understanding of Neptune's moons. Before the mission, astronomers knew of only 2. In a single flyby, Voyager discovered 6 more, and the total count has since climbed to at least 14 known moons. The largest, by far, is Triton, and it deserves its own spotlight because it might be one of the strangest objects in the entire solar system. Triton orbits Neptune backward, moving in the opposite direction of the planet's own rotation, a pattern astronomers call a retrograde orbit. This is extremely unusual. Most large moons orbit in the same direction as their planets spin because they form from the same swirling disk of material that built the planet in the first place. The fact that Triton breaks this pattern is a massive clue about where it actually came from. Scientists are now fairly convinced Triton wasn't born alongside Neptune at all, but instead began as a free-floating object from the distant icy Kuiper belt, the same far-flung region where the dwarf planet Pluto resides, and that Neptune's gravity eventually captured it. If that theory holds, the capture itself must have been an incredibly violent and chaotic event, one that threw any pre-existing moons into total disarray. Those original moons may have been flung out of orbit entirely or smashed into one another, and the smaller moons we see around Neptune today may actually be leftover debris from that ancient collision, material that eventually settled into new, stable orbits after Triton's arrival, reshaped the entire system. Triton itself measures roughly 2,700 kilometers across, making it the 16th largest object in the solar system. For comparison, our own moon measures about 3,400 kilometers across, so Triton is a bit smaller, but still a substantial world in its own right. When Voyager 2 photographed its surface, the results were extraordinary. Triton is coated in a layer of frozen nitrogen, with surfaces so smooth in places that scientists believe some kind of ongoing geological activity must be periodically resurfacing the moon. Scattered across that icy landscape, Voyager spotted active geysers, though not the kind you'd find at Yellowstone. These are nitrogen geysers, blasting columns of liquid nitrogen and dark dust high into Triton's thin atmosphere, where the material drifts downwind before settling back onto the surface, leaving long, dark streaks visible in Voyager's photographs. The likely power source behind these eruptions is sunlight itself, faint as it is at that distance, being absorbed by dark material buried just beneath the surface ice, converting into heat, and eventually vaporizing nitrogen from below to fuel the geysers. Triton carries one more astonishing piece of destiny. Because of its backward orbit, and because tidal forces are slowly dragging it inward toward Neptune, scientists calculate that in roughly 3.5 billion years, Triton will drift close enough for Neptune's gravity to rip it apart completely. The debris left behind would then form a brand new ring system, potentially one that would put Neptune's current faint rings to shame. It's not happening anytime soon on a human timescale, but on the timescale of the solar system, it's already written into the math of their orbits, an inevitable ending already in motion. The most recently discovered moon in Neptune's system is called Hippocamp, found in 2013 through Hubble Space Telescope images, and it holds the record as the smallest known moon orbiting Neptune. Voyager 2 never spotted it during its 1989 flyby, partly due to the limits of its equipment at the time, and partly because Hippocamp is simply so small and dark. Its discovery is a great reminder that both Earth-based and space-based telescopes have kept adding to our understanding of Neptune's family of moons long after Voyager moved on. Another notable moon is Nereid, discovered back in 1949 by astronomer Gerhard Kuiper, the very scientist the Kuiper belt is named after. Nereid has one of the most eccentric, elongated orbits of any moon in the solar system, a highly stretched path rather than a neat circle, which again hints at some ancient, chaotic disruption in Neptune's moon system, almost certainly connected to Triton's violent arrival. Then there's Proteus, another moon discovered by Voyager 2, and what immediately grabs attention when you look at it is its shape. It isn't round. Most sizable moons become spherical over time because their own gravity pulls them into that shape. But Proteus is lumpy, irregular, and battered, closer to a dark rocky potato tumbling through space than a proper moon. It's also one of the darkest objects known in the entire solar system, reflecting almost no sunlight at all. Before Voyager 2's flyby, humanity had no idea this moon even existed. It's worth pausing here to appreciate something genuinely remarkable about Voyager 2's ongoing journey. Launched in August of 1977, it flew past Neptune in 1989, and it has now been traveling through space for nearly 50 years. It's still out there right now. It has crossed the heliopause, the boundary where the sun's influence fades and true interstellar space begins, making it one of only 2 human-made objects ever to reach interstellar space. It still communicates with scientists on Earth, sending back readings from the very edge of our solar system and beyond. Its signals now take more than 17 hours to travel back to us at the speed of light. Every scrap of data it returns is a gift from a mission that began decades ago and is still delivering results today. Even with everything Voyager 2 revealed, Neptune still guards enormous mysteries. Humanity has visited exactly once with exactly one spacecraft for a relatively brief flyby, and there's still so much we don't know. We lack detailed maps of most of its moons. We don't fully understand the internal forces driving its extreme weather. We can't fully explain why its winds reach such staggering speeds. We don't fully grasp how its ring arcs maintain their concentrated shape over time. And there may well be additional small moons hiding out there in the darkness that we simply haven't detected yet. Scientists have floated proposals for future missions to both Neptune and Uranus, recognizing that ice giants remain the least explored category of planet in our entire solar system, despite being among the most common types of planets found orbiting other stars across the galaxy. Understanding these worlds isn't just about satisfying curiosity closer to home, it has real implications for understanding planets throughout the universe. Proposals for a dedicated Neptune orbiter, a mission that wouldn't just fly past, but would actually settle into orbit and study the planet and its moons in depth over years, have circulated within the scientific community for some time. A mission like that would take decades to plan, build, and fly, but the scientific payoff could be transformative. The images captured by Voyager 2, later supplemented by observations from the Hubble Space Telescope and other modern instruments, gave us our very first genuine look at one of the most remote and remarkable worlds in the solar system. What those images revealed wasn't a quiet, dark, frozen place sitting passively at the edge of our planetary neighborhood. Neptune is alive with motion, storms, and winds of almost incomprehensible power, moons with active geology, and rings that arc and cluster in ways science is still working to explain. It is a world of constant, violent, extraordinary activity happening in near total darkness, billions of kilometers from the sun's warmth. Every time we push our vision farther into the solar system, we're reminded of just how much is still out there waiting to defy our expectations. Neptune looks peaceful in photographs, that gorgeous, deep, tranquil blue instantly calling to mind Earth's oceans, the very same feeling that led the ancient Romans to name it after their god of the sea. But beneath that calm surface lies one of the most turbulent, extreme environments anywhere in our solar system. It is a world of supercritical fluids and supersonic winds, of ancient captured moons and mysterious dark rings, of temperatures spanning from nearly unimaginable cold to almost unbelievable heat, all contained within a single planet. What Voyager 2 delivered back in 1989 wasn't the end of Neptune's story. It was only the opening chapter of a story we're still learning to read. Those real images were the first words on the first page, and everything discovered since has only deepened our appreciation for just how extraordinary, complex, and endlessly surprising our solar system truly is. The outer solar system isn't some empty void. It's a frontier packed with worlds still waiting to be understood, and Neptune stands as one of the most breathtaking of them all. There's one more layer to this story, and it might be the most humbling part of all. Neptune is the only planet in our entire solar system that is completely invisible to the naked eye. Every other planet, Mercury, Venus, Mars, Jupiter, Saturn, even distant Uranus, can, under the right conditions, be spotted from Earth without any equipment at all. Not Neptune. It's too far away, too dim, too small in the sky. You need a telescope just to catch it as a tiny bluish dot. And yet this invisible, seemingly unreachable world orbits the very same star we do, tracing its slow 165-year loop around the Sun in the same solar system where our small, blue living planet spins and breathes. That invisibility has always added to Neptune's mystique. Ancient civilizations could look up and track the movements of the other planets, naming them after gods and building entire belief systems around their paths across the sky. Neptune, meanwhile, sat out there the whole time, completely unknown, its existence not even suspected for the vast majority of human history. It took an era defined by mathematics, telescopes, and rigorous scientific reasoning before Neptune became real to us at all, and it took a spacecraft launched in the 1970s, arriving 12 years later before we ever truly saw its face. The Hubble Space Telescope launched into orbit around Earth in 1990, just 1 year after Voyager 2's historic flyby, and it quickly became the next great tool for keeping an eye on Neptune from a distance. Hubble couldn't match the close-up detail Voyager achieved during its flyby, but it offered something Voyager never could: the ability to observe Neptune continuously across years and even decades. Through Hubble, scientists have tracked shifting cloud patterns in storm systems, watched dark spots form and dissolve, observed the atmosphere's brightness change as Neptune's 40-year seasons slowly progress, and even discovered new small moons like Hippocamp that Voyager missed entirely. Hubble transformed Neptune from a single snapshot into an ongoing, evolving story. More recently, the James Webb Space Telescope, launched in late 2021 and fully operational by 2022, turned its remarkable infrared vision toward Neptune and delivered images of a clarity that left the scientific community genuinely stunned. Webb's photographs revealed Neptune's ring system with a level of detail never captured before, showing not just the main rings, but faint, dusty bands that had previously been nearly impossible to photograph. The rings appeared sharper, crisper, and more clearly defined than in any image taken before it. Webb also managed to capture several of Neptune's moons in the very same frame, giving scientists a fresh perspective on the entire system all at once. Looking at those Webb images, after decades of Neptune exploration, genuinely felt like seeing the planet for the very first time all over again. This is really the essence of exploration. Every new instrument we build, every spacecraft we launch, every fresh generation of telescope we point at the sky reveals something we simply couldn't see before. Neptune was invisible for nearly all of human history. Then it became a faint dot, then a blurry disk. Then, for a handful of days in 1989, Voyager 2 swept past and handed us our very first real, detailed close-up photographs of an actual living world. And in the years since, our picture of Neptune has only grown sharper, richer, more layered, and more surprising with each passing decade. Neptune rewards every bit of curiosity and technology we throw at it. What we know for certain is this: Neptune is not some distant, silent, quiet corner of the solar system. It is a world of ferocious storms and screaming winds, waiting billions of kilometers away, spinning endlessly through the darkness, wrapped in electric blue clouds, its rings catching what little sunlight reaches that far from home. We've finally seen its face. We've only just begun to understand what lies behind it. If this journey through Neptune's story left you as amazed as it left us, share it with someone who loves space as much as you do. Drop a comment telling us which fact surprised you the most, and subscribe if you want to keep exploring the far reaches of our universe together. There is so much more still waiting out there for us to discover.